Morning, Madam Rosie. Today, me and my teammates are going to present about reverse engineering. Before we start our presentation for today, I would like to introduce myself. My name is Jutal Vinjolip and my number matrix is 07DKM21F0141. Without wasting any time, this is the table of content which consists of introduction, process and device, mechanism that make the device work, material use and suggested improvement in terms of environment and sustainability, conclusion and reference. So first off, we will start off for the introduction of reverse engineering. So reverse engineering, also known as back engineering, is the process of disassembling software, machine, aircraft, architectural structure and other products in order to extract design information from them. Reverse engineering frequently entails disassembling individual components of fragile products. The reverse engineering process determines how a part was designed so that it can be recreated. When purchasing a replacement part from an original equipment manufacturer, OEM is not an option. Companies frequently use this approach. Besides that, the process of obtaining a geometric 3D model from 3D points acquired by scanning or digitizing existing products is known as reverse engineering. So the first phase of process is scanning. There is two different types of scanning, which is contact scanner and non-contact scanner. Contact scanner is the object must be physically in contact with the scanner in order for the scanner to probe and record its dimension. For non-contact scanner, use utilize ultraviolet radiation, ultrasound waves, and radiation that reflect back from the object surface and is recorded by the scanner. In this case, both methods can be used as 3D scanners, and it depends on us which method is work efficiently with to make a 3D part. Phase 2 is point processing. This phase involves importing the point cloud data, reducing the noise in the data collected, and reducing the number of points. It allows us to merge multiple scan data sets and take multiple scans of the part to ensure all required features have been scanned. Multiple scan planning has a direct impact on the point processing phase. Cloud points are a set of data points in space that represent a 3D shape or object. They are produced by 3D scanners or photogrammetry software, which measure many points on the external surface of objects. Final phase for process is phase 3, application geometric model development. Geometric modeling is a necessary tool for dealing with hull shapes and provides useful operation for a variety of purposes. Surface modeling and surface-to-surface computation techniques are introduced. So the final phase for process is application geometric model development. Geometric modeling is a necessary tool for dealing with hull shape and provides useful operation for a variety of purposes. Surface modeling and surface-to-surface computation techniques are introduced, as well as their application to shape hull design and analysis.
Thank you, Jude. First, I will introduce myself. My name is Barnabas David and my matrix number is 07DKM21F1071. And so, next I will present about the mechanism that make the device work. A car battery is an electrochemical cell that transforms chemical energy into electrical energy. The operation of a car battery can be broken down into the following steps. Chemical reaction. When you connect the car battery to an electrical load, such as the starter motor, a chemical reaction occurs between the lead plates and the electrolyte solution. This chemical reaction causes an electrical current to flow from the battery's negative terminal to its positive terminal. Second one is electrolyte solution. The electrolyte solution is a sulfuric acid and water mixture that acts as a conductor for the electrical current. Next is lead plates. Lead plates serve as the batteries, electrodes, and provide the surface area for the chemical reaction to take place. Next, separators. Separators are thin sheets of material, typically porous plastics, that keep the lead plates from touching and short-circuiting the battery. The separators also allow the electrolyte solution to freely flow between the lead plates, ensuring that the chemical reaction is distributed evenly. Next, casing and terminals. The battery's casing is made of plastics or hard rubber and is intended to protect the battery's internal components from damage. The terminals, positive and negative, are located on the battery's top and are used to connect the batteries to the vehicle electrical system.
Thank you, Barnabas, for the presentation. And before I start my presentation, I would like to introduce myself. My name is Stephen Sibyl Jr. and my matrix number is 07DKM21F1055. And in this slide, I would like to present about the material used and suggested improvement in terms of environment and sustainability. A lead-acid car battery is typically constructed with the following materials. So number one, lead. The primary material used in the battery's electrode construction is lead. It is a heavy metal that is toxic to both humans and the environment, and the production and disposal of lead-acid batteries have serious environmental consequences. And we move on to the number two, lead oxide. Lead oxide is used in the production of battery electrodes. It is produced by oxidizing lead and aids in increasing the energy density of the battery. Number three, sulfuric acid. The electrolyte in the battery is sulfuric acid. It is highly corrosive and toxic substance, and it is safe handling is essential. Next, we move on to number four, the plastic. The casing of the battery is typically made of plastic and durable and a lightweight material that can withstand the corrosive effect of sulfuric acid. And number five, copper and steel. Copper and steel are used in the terminals and in terminals component of the battery. Both are recyclable and can be discovered during the battery recycling process. And to the next slide, these are now several environmentally friendly and more sustainable alternatives to lead-acid batteries, which is number one, lithium-ion batteries. Because of the high energy density and efficiency, lithium-ion batteries are becoming increasingly popular in electric vehicles and hybrids. They are also less harmful to the environment than lead-acid batteries because they do not contain toxic heavy metals. Lithium-ion batteries can also be recycled with up to 95% of the metal recovered. Next to the sodium-ion batteries. Sodium-ion batteries are a promising lithium-ion batteries substitute. They use sodium instead of lithium because it is more plentiful and less expensive. Because of they do not contain toxic heavy metals, sodium-ion batteries are also more environmentally and friendly. Sodium-ion batteries are also recyclable. And these are the suggested improvement. Use of sustainable materials. Another enhancement that can be made is the use of environmentally friendly material in battery production. For example, using recycled materials or environmentally friendly materials in the manufacturing process. Reduction of waste. Waste reduction is also important for battery sustainability. This can become accomplished by reducing the amount of material used in the battery production, designing batteries to last longer, and developing effective battery disposal programs. That's all from me. Thank you so much. And the next slide will be presented by my friend Isaac.
Thanks to my friend. So my name is Jordan Isaac George. My matrix number is 07DKM21F1053. So we move to the conclusion. Reverse engineering can help you judge a product more deeply and reach beyond the typical criteria of functionality, cost, vendor stability, and attractiveness of the user interface. It is burgeoning when considering the high cost of many software deployments and the low cost of reverse engineering. A few weeks of effort, it also benefits the software community as a whole, as a software costs too much, is of uneven quality, and takes too long to deliver. Despite software engineering, we still have too much flawed software and resulting software crisis. So we move to the reference. So the first reference is we got at Reverse Engineering and Industrial Perspective by S. Chattopadhyay and S.K. Basu. So the second reference is Lead Acid Battery Technologies, and the third one is Chapter 4 Notes, Reverse Engineering Slide, and the last one is at website autobatteries.com. So that's all from us. Thank you.